So when I asked Dr. Martin Terry of the Cactus Conservation Institute about where I should start with this presentation, the first thing he said was, I assume you know that each one of those three topics, habitat, growth, and care, is enormous in scope. So anything you present must be prefaced by a disclaimer that your talk will merely be scratching the surface of each of these three subjects. So maybe this talk should be more aptly called Scratching the Surface. We are briefly going to fly through the different species and varieties of Lophophora, because this is going to be more of a practical, hands-on approach to going out there, getting your hands dirty, and actually getting to enjoy the presence of this beautiful plant. We're also going to take a look at how and where Lophophora grows in the wild, because in growing Lophophora yourself, it's good to have a true understanding of where it comes from. This will help you closely mimic and reproduce the environment in your home. Most importantly, don't be afraid of everything having to be perfect. You will make mistakes along the way. In fact, the more mistakes you make, the better, because making mistakes will give you the opportunity to improve and get better at growing. Through trial and error, you'll be able to grow bigger, healthier plants that you can enjoy and share with the world. So basically, the point of this presentation is to inspire you to get out there and try growing Lophophora yourself. So let's get started with the basics. The genus name, Lophophora. So the origin of the genus name Lophophora is from the Greek lophos, or the crest or tuft on the head of a bird, as in the case of this beautiful bird aptly named Lophosphingus, for the beautiful hairdo, a tuft of hair upon the crown, basically that it's crested, like this Chinese crested dog. And phora, for phorius, a bearer, in reference to the tufts of hairs borne in each areole. So basically, crest bearer, or that it bears a crest, or bearer of the crest. So now, anytime you hear the name Lophophora, you will know that its name means crest bearer, because it has crests. Now that we know about the name and what it means, what are the different types, variations, or species of Lophophora? Well, there's actually quite a bit of contention about what is considered an official species of the genus. Should they be called species, subspecies, or just varieties? You can say pretty much everyone recognizes and accepts Lophophora williamsii and Lophophora diffusa. So for the purpose of this presentation, we'll just leave it at that. The major difference between the two is that Lophophora williamsii is the most potent of all mescaline-containing cacti, while Lophophora diffusa has little to no mescaline. Instead, it contains pelotine, which is also why Lophophora williamsii is also more of a bluish green with tougher skin, and Lophophora is yellowish green. It has yellowish green skin, not as defined, or in other words, diffused ribs and softer, more delicate skin. Lophophora diffusa is also self-sterile, which means for flower fertilization, it is only able to mix with its own kind. This is another reason why there are so many different varieties of Lophophora diffusa, because there's a lot of mixing between plants. Lophophora williamsii, on the other hand, is self-pollinating, which means a flower can technically pollinate itself. However, if, when possible, you can give it a helping hand by pollinating it with another Lophophora williamsii, you will reap additional rewards, which we'll get to shortly. This topic alone is worthy of its own presentation, but because the different varieties of Lophophora are so interesting, we'll cheat and briefly take a look at just a few of them. Okay, so you look at this list and you think, wow, okay, what am I looking at here? What does this all mean? Well, we know Lophophora williamsii and Lophophora diffusa. Then we have Alberto Wojtycki, named after Alberto and Wojtek, who must have become great friends after making that discovery. But what does that plant have to do with crostata or cespitosa, and how do they relate? Well, to help simplify things, let's rearrange things a bit. Okay, now this is feeling a bit better, but it still seems a bit confusing. Let's try to quickly shed some of this mysticism. Keep in mind, this is my attempt at making sense of this. It helped me, so it might just help you too. But take it with a grain of salt, because it seems everyone is very picky about how to approach this topic. We have Lophophora williamsii and Lophophora diffusa, whose differences we just went over. Then we have varieties of the two species in blue. Then different unusual forms that any of the species or varieties can sometimes exhibit, as well as variegata or variegated, which kind of falls under forma, but not really, because it has to do with the pigment, not the form of the plant. Phew, we did it. Does that kind of make more sense now? So now let's take a quick look at how plants that exhibit some of these traits actually look like, starting from obviously the best one, crostata. So crostata, or cresting, is basically what happens with Lophophora when a genetic mutation occurs and cell division begins to occur laterally. Some of these plants are truly spectacular in that they keep expanding as if they have no intent to ever stop. And this all happens sideways, so you can only imagine the mesmerizing effect of the resulting plants. Now, obviously, if you had a plant like this, the first thing you would think is, how do I make more of them? Well, because it's a genetic mutation, you might not get the same effect through sowing its seed. Because of that, it's usually best to propagate plants exhibiting this form through carefully taking a cutting and grafting it, after which you can always degraft it to produce a fully formed plant. Then that unusual variegation mutation that didn't seem to fit anywhere. Let's look at that one. So this occurs when there is a chlorophyll deficiency in the plant. The resulting condition produces a variation in color and patterning on the epidermis of the cacti. It too can be propagated through grafting. Finally, we have another favorite of mine, cespitosa. So the word cespitosa, I'm not sure if I'm saying it right, but that'll do for now, means growing in tufts or densely clumped. Aside from its natural beauty, one thing I'm truly amazed with is that the fact that it's been known to split to form multiple completely separate plants. It does this by stretching out, creating a new head, and then disintegrating the old connection. It does this for survival. The more plants it can produce, the better its chances of making it out there in this cold, harsh world. This plant is actually the plant from my cactus grafting video. And I'll return to it in a bit when we get to propagation through cutting and rooting pups. Okay, so this was just a taste of the different forms and varieties of Lophophora. Hopefully, my approach and understanding of the genus didn't ruffle any feathers. But on the topic of ruffling feathers, if you really want to open up a can of worms, I suggest diving into this special edition of the Czech journal Cactus, available in English. And from what I've read in books on the subject, it seems to have riled up a whole new kind of taxonomical tornado. That's all I can say. So now that we know some of the types of Lophophora that are out there, let's see where we can find them in the wild. Well, here we see a distribution map for the genus Lophophora. It's native to the United States and Mexico. In the United States, it's native to Texas from Presidio County, or Big Bend National Park, and south right along the Rio Grande River to Starr County, Texas. In Mexico, its range continues south through northeast and north central Mexico to Querétaro in central Mexico. It's mostly found in rocky limestone substrates and deposits of clay, silt, sand, and gravel left by flowing streams in river valleys, or also known as alluvium. That's derived from calcareous parent material. Calcareous means mostly or partly composed of calcium carbonate. In other words, containing lime or being chalky. That's taken straight from the book Cacti of the Trans-Pico and Adjacent Areas. But it's all nice and dandy looking at a map and seeing everything from the comfort of your own home. But what does this habitat actually look like? What would we see if we were down in the desert flats, kneeling under a bush with our face buried in sand next to a healthy bunch of Lophophora? Well, it would look much like this. This is Rio Grande Valley in the Big Bend area. So alluvium is eroded soil that's been reshaped by water in some form. The water moves the soil and redeposits it in a non-marine setting. Alluvium is made up of a variety of materials, including fine particles of silt, clay, and larger particles of gravel and sand. Take a mental note of that because this is all very important to know when it comes to reproducing that environment at home. Lophophora seeds are often spread through the water after rainfall and germinate under the shade of desert shrubs and bushes. So how do we mimic these natural environments in our own home? Well, that's exactly what we're going to do. We're going to get to next by learning a few techniques on growing and propagating Lophophora. This next slide may look familiar if you join me for part 1 of this presentation. Of course, the easiest way to propagate the plant is simply by decapitating it. I know it sounds horrible, but it's true. You cut the plant at the bottom of the crown's soft tissue right above the stem and set it aside to callus over. You can also apply rooting powder to the bottom of the crown. Once the wound calluses over, place it in a new pot on top of freshly mixed Lophophora potting mix. Don't water it. Leave it for a few weeks, after which you can give it a light spray. If it's on loose soil, you can always gently lift it up to see where it is with its root formation, but it's usually best just to have patience and faith in the process. Just leave it alone and let it do its thing. It might take a month and a half or even longer for new roots to start forming from the bottom of the crown. Once roots form and you start watering it again, you will start to notice the plant looking bigger, juicier, and healthier than ever before. The crown should form roots on its own, even if left on a paper towel. Once the wounds dry, I like to put mine on some soil to help stimulate the process. As horrible as this sounds, sometimes the only way to save a plant is exactly by rerooting it. It might be because of root rot or a bug infestation, but most often this will work to save your plant. Give the root time. It may take the root up to a year to start forming pups again. And here is what to expect when the root starts producing new pups. Speaking of pups, the next best way to propagate your Lophophora is by cutting and rooting pups or offshoots. Lophophora naturally forms side shoots from its main crown. You can cut these off, let their cuts callus over, or apply a rooting powder and grow them as separate plants. I've done this numerous times, and as long as the pup is not too small, it usually works wonderfully. And when I say too small, I mean a good size would be about the diameter of your finger. Be sure to keep the rooting pups in a shadier spot to keep them from drying out. After a few weeks, you can give them a light spray. I was actually able to save this plant using the same exact method. I had to split it up because the grafting stalk it was on had died. I scraped away the old grafting stalk and managed to save most of the larger heads. I even planted some of the elbow-like parts that are still growing and producing new pups. I just recently repotted all the pups because they were next to some other plants that were infested with mealybugs. They now all have well-established roots. I even saved the main crown of the plant, even though I was afraid it would die. It doesn't look very appealing, but it's still alive and producing new pups. So it just goes to show you that these techniques work, and you shouldn't be afraid of trying them on your own. Okay, so you've rooted all your pups and you want the thrill of sowing your own Lophophora seeds. Well, usually it's best to ask your fellow gardeners, your fellow growers, to see who has fresh seeds they are willing to trade, sell, or give you. That way you can ensure they're fresh and your germination rate will be great. We have a great community at the Toronto Cactus and Succulent Club. Most members actively grow their own plants, and many have at least some seeds to spare. Be sure to check out the TCSC Grow Room. Jacqueline is also working on a seed list, so don't be shy to ask. Going back to the seeds, it's usually best to sow seeds within a year of when they're collected. However, when stored under proper conditions in a cool, dark place, they can usually last a few years. I store mine in the fridge. Keep in mind, just like with anything else, the longer you store them, the lower your germination rate will be. That's also good motivation to get started now, because somewhere out there, there are fresh seeds getting old, just waiting, begging for you to plant them. A few other mention-worthy tips and tricks. Some people use powders to protect seeds from fungus and help improve germination rates. You can also experiment with putting the seeds in the freezer for a brief period of 1 to 2 weeks, and then the fridge for the same amount of time right before sowing them, to trick the seeds into thinking they have gone through a winter season. For best germination, try to sow between March and September, but you can always get away with sowing indoors during the winter months with a grow light or a south-facing window. All you need is a clear plastic box with a cover about 3 inches deep. Leave around 2 inches between the soil and the plastic cover. The soil shouldn't be more than 1.5 inches deep, because then it'll hold too much moisture. Fill it with either 50% soil and 50% perlite, or any general purpose cactus and succulent soil. I like to use ProMix HP as my soil because it has no added nutrients. Remember that seedlings will be locked in a damp container for weeks or even months. So the less fertilizer the soil has, the less nutrients fungi will have to grow. I've heard that some people also use bird sand or aquarium gravel to cover the soil and help prevent the spread of fungus, but I haven't tried that yet. It's a good idea to sterilize the soil, because you will be sealing the container for a few weeks, which means you will also be creating perfect conditions for various fungi, mold, and bacterium to prosper. One way to do that is just to pour boiling water over the soil and let it sit and drain out and cool. That's how I first got started. It might not kill everything in the soil, but it'll help. There are numerous of other hardcore methods you can look up online. Some include pressure cookers using a dilute sulfur solution, or you can even steam the soil in a pot or microwave it. Do some research online to see which method works best for you. If you're not sure, just start with a simple boiling water from a kettle. Once it's cool, it should also have the right moisture content for your seeds. The soil should be moist, but not shiny. If it's shiny, it's too wet. You should be able to dab a spoon into it without the water pooling in the depression. Sprinkle your seeds along the surface and lightly press them into the soil with a spoon. Prevent the formation of fungus. You can apply the sand with a salt or pepper shaker to ensure it's only a light dusting. Close the box and keep it in a spot with bright shade. Direct sunlight in the early stages can quickly kill your seedlings. And the best temperature for germination is between 20 to 30 degrees Celsius. Germination starts after a few days and lasts for about 3 weeks. Keep an eye on the seedlings every day to see if you spot any unusual fungal growth. If you see anything, you can use a fungicide like diluted sulfur. After around 4 to 6 weeks, you can start hardening off the seedlings by slowly removing the plastic cover a bit each day. Don't worry if not too many of the seedlings germinate. Sometimes more seeds will germinate later in the process. If you did an amazing job with sterilizing the soil and you find that your seedlings are doing well, you can even keep them covered up for up to 6 months. You just have to keep an eye on them and try to listen to their needs. If you see any weird growth starting to form, it's usually best to start to carefully scrape it away and start opening them up. As you do, be sure to keep the soil moist. You can do that by misting it with a spritzer bottle. And the older they are, the more you can start introducing them to more intense light. If they change color to a dark red or purple, you'll know that they're getting too much light and you can put them into a shadier spot. Keep them in the same spot, in the same pot, as long as you can. The older they are when you transplant them, the higher their chances of survival will be because their roots will be stronger and more developed. When you do transplant them, try to move them in clumps of soil so as to protect their roots as much as possible. On the topic of repotting, repotting removes any unwanted pests accumulated in the soil, as well as gives you a chance to check on the state of the roots and lets you stay on top of root rot. I try to repot my older plants at least once a year, but try not to repot seedlings younger than a year old. After repotting, give the plant at least a week to heal and prevent the risk of root rot from any damaged roots from repotting. Now you're ready for grafting. If you haven't seen my grafting video, be sure to check it out. The best months for grafting are between May and August. Ideally, both scion and rootstock should be in their growth phase, plump and juicy. Water heavily a few days before carrying out the graft. Grafting on Parasciopsis can be done using cellophane and small hair elastics. Graft only on the fresh new green growth of the Parasciopsis because the stalk further down gets too woodsy and hard. The most important thing to remember is that you're connecting the tissues of two plants and you want to make sure the moisture stays locked in until they grow together. Set the Lophophora seedling slightly off to the side so that the inner rings overlap. Experiment to find your own grafting technique. Here's my first ever grafted Lophophora. Here it is after I accidentally dropped it. Here it is again after a few days when I brought it in with me to our grafting workshop at the Toronto Botanical Gardens in 2014. Some people thought it would die, but here it is again in 2020. And it was just fine until 2020 and until the rooting stock died and I had to split it up. But it just goes to show you, so here it is again, split up. Don't be afraid of making mistakes because that is just the beauty of the process. And to pot all those little guys, I had to know a bit about which soil to use. So let's learn about soil. Lophophora is prone to root rot. So the better draining the soil, the happier it'll be. Ideally, use a coarse grain material, 3/16 to 3/8 inch in diameter. These will provide aeration and proper root formation. Examples of good soil materials include pumice, coarse sand, gravel, 1/4 inch limestone screenings, akadama, and perlite. One of the benefits of using pumice is that the plants release acids into the soil, and pumice helps stabilize the soil's pH levels. Some people also use clay pellets, aquarium gravel, and pebbles. I also like to use a small amount of earthworm casings in my mix, but in most cases, no more than 10% of the mix. I've even heard of growers substituting soil for coconut coir. It's supposed to have antifungal properties, but I have yet to try it myself. Experiment with different mixtures and see which works best for you. Once you pot your plants and they've had some time to heal their roots, you'll probably want to water them. If you don't have access to rainwater, you can also improve the quality of the water by either using filtered water and/or water that's been left out for the chlorine to air out. You can use trays and water from below to let the water completely soak through the soil in the container. And by soaking the container from below, you ensure the substrate will be evenly moist. Water anytime the soil dries out completely. Frequency really comes down to where you keep your plants and how quickly the soil will dry out. You can also lift containers to gauge how light they are and judge when to water them that way. The only exception to the rule is between October and March. Either don't water at all, or if it's very warm where you're keeping your plants, water sparingly, and then gradually start watering again in April. Artificial light can also help for seedling growth or for growing during the winter. You can do some research online to see which lights work best for you. Recent advancements in LED technology make them a good choice. Usually lighting temperatures of 6,500 Kelvin are used to stimulate growth and 2,700 to stimulate flowering. Don't underestimate the power of the sun. Lophophora burns easily, so once it gets warm out, be sure to reintroduce your plants to the sun gradually. I've burned my plants many times, and now when I bring them outside, I usually keep them in a bright, shaded spot. If you have or can get a greenhouse, use it. Don't force the growth by over-fertilizing, because Lophophora naturally grows slowly. Remember, we're trying to reproduce natural environments with natural processes. In October, fertilize with potash fertilizer to strengthen cell walls for the winter. Dormancy also occurs naturally for Lophophora in the wild. Less rain, cooler weather, and the plant goes to sleep. And trying to mimic that at home, you'll need to provide lower levels of heat and light during winter months. Otherwise, if your plants are warmer, let's say around 8 to 15 degrees, you'll need to water more frequently. If you're able, warmer than 8 to 15 degrees, you'll need to water more frequently. If you're able to keep your Lophophora plant in cooler temperatures, try not to water it at all. And if you feel it really needs it, only sparingly. Dormancy is a good thing for mature plants. However, I tried hibernating my younger plants and many of them didn't handle it well and most of them died. Dormancy is the secret to having flowering Lophophora. So that's really important to remember. Now, temperatures. Temperatures in the desert go from extreme heat during the day to sometimes near freezing at night. Try to mimic that environment. And if they are outside during the day, I try to put my plants outside at night. Sorry, if they're inside during the day, I try to put them outside at night to help mimic drops in temperature. If you remember at the end of part 1 of this presentation, someone had asked about ways of increasing mescaline production. So I actually asked Dr. Martin Terry, the expert in the study of Lophophora, who graciously provided the following in-depth response. He said, each individual peyote plant has its own physiological limitations, plus the limitations imposed by hours of daylight and a host of environmental limitations, including moisture availability, which is affected by a large number of factors, including day length, amount of rainfall, temperature of the plant per se, excessively high temperatures resulting from direct sunlight on the plant, and or high temperatures resulting from heat absorption, heat absorbed directly from nearby soil and rocks, and from water when it rains in the desert. Then you consider the differences in the rates of heat absorption between dark colored soil and light colored soil. And the list goes on and on. As a general rule, metabolism of all kinds runs faster in hotter environments than in cooler environments. And that would apply to all sorts of living organisms. But if you're interested in detecting quantitative differences in complex systems like plants and animals, then you had better get yourself a good, for example, expensive thermometer that works across the temperature range you'll be working in, and start taking temperature measurements and notes about the environment that produced those readings. An additional factor affecting rates of in vivo mescaline synthesis by a given individual peyote plant is the age and size of the plant. In the case of peyote, there is a very wide range of environmental temperatures that affect the in vivo rates of mescaline synthesis in the plant. Obviously, peyote can neither move voluntarily to a shadier, cooler spot in its habitat during the hot months of the year, nor move to a more fully exposed spot to avoid frost in the winter, which explains why the very survival of a given peyote plant may depend upon its location and habitat, and particularly its degree of exposure to severe heat in summer or severe frost in winter. So in essence, temperature stress may play a role in the rates of mescaline synthesis in the plant. So that's something to keep in mind. Root rot is usually caused by overwatering or improper mineral content and drainage of substrate. Bugs happen. You might carry them in on another plant or even on your clothing. You can try controlling them with alcohol swabs, but it's usually best just to throw out the old soil and start fresh. Throw out old substrate and be sure to properly disinfect the old pots before using them again. This time, try increasing mineral content of the substrate or grow in pure pumice. If you want to harvest your own seeds, you can simply pollinate flowers when you see them open. They open in the morning and close in the afternoon. Although the plant is self-pollinated, it's best to cross-pollinate between two different plants of the same variety. This will give you more seeds and a higher germination rate. Seeds resulting from self-pollination will give you less seeds and a lower germination rate, below 50%, and that's according to Dalibor and his experience. So you can use a small brush or a Q-tip. Dalibor before also mentioned making your own brush, if you remember, using human hair, which the pollen seems to stick to better. But don't worry if you don't see any pollen, it's usually very fine and hard to see. I try to mimic the actions of an insect, fly or bee. You know, I also try to mimic how long the insect would be in there and how it would move around in the flower. Yes, I know you think I'm crazy, but that's okay. Use a tiny brush and run it along the outside pollen-covered anthers, and then rub it on the inner stigma. You're basically trying to touch the pollen on the tiny outer heads and transfer it to the middle head. The pollen-covered anthers bend towards the stigma when you touch them from turgor pressure, or because they're stigmotactic anthers. The flower opens and closes for a few days, and you can repeat the process over the few days the flower opens to help improve the results. Once flowers close and form fruit, and the fruit dries up, pick the fruit and carefully pull out the seeds. This may take up to a few months, so be patient. Clean the seeds, rubbing them in between your fingers to remove leftover parts of the fruit. Cleaning the seeds is important because it will reduce the chances of mold formation further in the process. Most Lophophora williamsii varieties are self-fertile. However, according to the Cactus Conservation Institute and greenhouse breeding experiments by Bohata and colleagues in the Czech Republic and by Kores in Germany have shown that plants from the L. huazachi population are self-sterile and therefore obligate outcrossers. Lophophora diffusa, Lophophora frici, and Lophophora coercii also require cross-pollination. If you're concerned with varietal purity, you can have separately labeled paintbrushes for each variety of plant. And if you really want to ramp up your seed production, I've heard grafting is the way to go. And if you're in there cross-pollinating your flowers, you might get curious and maybe even a bit experimental. You might look over at a flowering turbinocarpus and think, I wonder what would happen if, and that is called hybridization. And if you're looking to come up with the next Lophophora williamsii, the Jordaniana, you better start now. And there are plenty of sources online that will guide you in the right direction. And that's it. I hope you have found some of this useful and that it's inspired you to try it yourself. And remember,
No sound, Adam.
Did you not hear that?
No.
I knew it. I knew it. Anyway, there was a song and it was great. I wish I could share it with you. But basically, it said, it has to start somewhere and it has to start somehow. What better place than here? What better time than now? So go out there, get it done. And yeah, I hope you guys are all inspired.
Yeah. Thank you, Adam. Thank you as always. It was brilliant.
Absolutely.